Today's lecture is on moles to volume or volume to moles, and it would be very helpful if you had out right now your mole road map, which looks just like this on the screen. And because we're going to be referring to this, and we want to add some stuff to this as well. So this is our mole road map, and as we've talked about before, it allows us to go from one place to another place, convert between moles or atoms or molecules or formula units or grams. And we're going to add one more thing today too. So one thing we want to add in here is, it says up here in the right hand corner representative particles, and so let's write in the word atoms, and let's write in the word molecules and the word formula units. Just because any of those can be used for particles, and we use Avogadro's number to get there or get away from that. Down here at the very bottom we have mass, and so we probably want to write in grams. And then up here in the left-hand corner we have, it says volume at STP, and we're going to talk about that. Let's write in the symbol liters, because that's what we're going to be using. So that gives us an idea of those units that are associated with either volume, which is liters, or representative particles, atoms, molecules, formula units, or mass, which is grams. Okay? So we're going to be talking about today this portion of the mole road. We're going to be going from either moles up to liters, or we're going to go be liters down to moles. And so that's essentially what's happening today. So scroll down here a little bit. And so the story so far, we've talked about what a mole is equal to. And we said that a mole is equal to, we know, 6.02 times 10 raised to the 23rd power, and that could be atoms or molecules, depending if we're talking about a molecular compound, or formula units, if we're talking about an ionic compound with a metal and a non-metal in it. So we'll scratch that out there. We also said a mole is equal to molar mass. And that's sometimes talked about as atomic mass, means the same thing. That's measured in grams. Now, we're going to add a new one today, and this one refers to gases. And a mole is going to be equal to a value, and the value is 22.4 liters at STP, and we'll talk about what STP means in a moment. So if you have a mole of gas, you have 22.4 liters of gas. It doesn't matter what gas it is, it's all right about the same, 22.4. And to give you an idea, well, think about a 2-liter bottle. A 2-liter bottle, you've got 11 of those, plus another one that's just a little less than half full. That's 22.4 liters. Now let's talk about what standard temperature and pressure means here. So standard temperature and pressure means, because gases are so easily influenced by temperature and by pressure, we have to have a standard temperature and a standard pressure. The standard temperature is a measure of 0 degrees Celsius. 0 degrees Celsius. And there's another temperature measurement that we sometimes use with respect to gases, and it's a measurement called Kelvin, and it's 273 Kelvin. Those are both standard temperature. So a gas has to be at standard temperature, 0 degrees Celsius or 273 Kelvin. They're both equal to be considered standard. The pressure is the measure of how molecules, the force that they exert when they run into an object. That's what pressure is. And we feel pressure changes sometimes, like if we go up in the mountains or in an airplane, you feel pressure changes in your ears, or we feel pressure changes in our ears as well when we go underwater, dive down to the bottom of a swimming pool. Now, standard pressure is what sea level pressure usually is measured in a couple different ways. Atmospheres is a type of measurement of pressure. So 1 atmosphere, which is equal to 760 millimeters of mercury, which is equal to 101.3 kilopascals. Any one of these 3 measurements, and there's a few other pressure measurements as well, but these are the 3 main ones we're going to talk about. These 3 pressure measurements would all be standard temperature and pressure. So oftentimes you'll see a problem that says STP. That just gives you permission to use 22.4. That's all we're talking about there. So not a big deal. All right. So let's get into problems involving mole calculations and liter calculations. So here we have our mole road down here below, and we have an example problem. Once again, I'm just going to put liters right here. Now it says calculate the number of moles in 85 liters of CO2 at STP. Once again, that STP just gives us permission to use the mole road. That's all it is. First thing I'm going to do is I want to identify my known value. And so it says my known value is 85 liters of CO2. That's my known. So I'm going to go ahead and start this problem off. And I'm going to go 85 liters of CO2. And the next thing I want to do is I need to identify my unknown. What I'm looking for in this problem is calculate the number of moles. Okay, so there is my unknown. I'm looking for moles. So I'm going to write the word moles right there. Now, just like I did before with all the other problems, I'm going to take the unit that is right here, and I'm going to rewrite it down there. Rewrite liters. Now, I can use the mole road now, and again, we talked about this before. Whatever you have here is where you start on the mole road, and whatever you have here is where you end on the mole road. So it looks like we're starting at liters, and it tells me we're starting at liters because it says liters there, and we're ending at moles. And so the conversion factor to go from liters to moles is this conversion factor right here, 1 mole over 22.4 liters. I just took that conversion factor, put it right up there. And so this type of problem, because I have a number on the top and a number on the bottom, becomes a division problem. So I'm going to grab my calculator here. I'm going to run this through my calculator. So I have 85 divided by 22.4. Now it gives me a number that's pretty long, and it's a small number with lots of decimals, but I'm going to round it off. Because this is 2 sig figs, 85 is 2 sig figs, I'm just going to round it off to 2 sig figs. So I get 3.8, we'll call it 8. And the unit of liters cancels, and the unit of liters cancels, and we're left with an answer, moles, and so we have to put the word answer moles, just like that. And if we wanted to throw in there as well, we could say 3.8 moles of CO2, just like that. And that's how we get that answer. Okay, let's look at one more problem here. Scroll down again, and here we go. Again, I'm going to throw liters right there on my mole road, and let's do the same thing. Let's identify some things. So it says if 4.5 moles of helium goes into a balloon at STP, what is the volume of the balloon? So my known quantity, that my given, is 4.5 moles of helium. Okay, so I'm going to write 4.5 moles of helium, just like that. And then it says it goes into a balloon at STP. STP just means I'm allowed to use the mole road. What is the volume of the balloon? Okay, so we're going to we're converting to volume. That is our unknown. Now if we look at the mole road, the unit for volume is going to be liters. And so we're going to go ahead and write liters right there. Again, we're going to take this unit moles, and I'm going to write it right under the word liters, moles. And so where we're starting from on this one, we're starting at moles, which is right here on the mole road, and we're ending at liters, which is right here. So there is my conversion factor, and that conversion factor is going to be 22.4 liters over 1 mole. And notice how those numbers all match up. And so this becomes, because we have a number on the top and a number on the top, it becomes a multiplication problem. 4.5 multiplied by 22.4, and I get an answer of 100.8. Now, my known quantity is 2 sig figs. So I look at this and I want to put this into 2 sig figs. It's currently 4 sig figs. How about I put it in scientific notation? I'm going to move the decimal 2 places. We'll call it 1.0 times 10 to the second, and the unit is going to be liters. And that is 2 sig figs, because a trailing 0 to the right of a decimal is significant. And I'm going to throw in helium as well here, just like that. So 1.0 times 10 to the second liters of helium. Alrighty, and that is how we do moles to liters, liters to moles calculation. Hope you have a nice day.